Welcome back, ladies and gentlemen. This is Dr. Robinson again, and we're going to continue our studies, and we are talking about square root functions. The principal square root function f of x equals the square root of x, usually referred as the square root function. It is a function that maps the set of non-negative real numbers onto itself. Parent square root function f of x equal square root of x, that's the parent function, and you may sometimes see it written with a few other letters added onto it. F of x equals c times the square root of x minus a underneath the radical sign plus a b. So please note the domain of this function is all non-negative numbers, real numbers. So we're talking about positive numbers that are real. The range of this function is also non-negative real numbers. So we're talking about getting out of the imaginary zone. Okay, so here's our first graph. So we want to graph f of x equal to square root of x, and also here for this function we'll see how these letters play a part of this function. So let's also put a c in there. Okay, so we have our x values. We start off with 0. Why 0? Because the square root of 0 is equal to 0. We then try 1. Square root of 1 is a good number to pick because the square root of 1 is 1. Then notice we skip down to 4. The square root of 4 is 2. Now we could have used 2, but the square root of 2 does not come out to a nice integer like we would like. So that's why we skipped it. But it is viable in our graph. So when we graph our numbers 0, 0, there's that point, and 1, 1 is that point. If we tried to graph 2, we would have to get the square root of 2, and that would give you something like 1.4 something for 1 something, and that would be 1.14 something up here, and it'd be a little over this dot, and it'd be a little bit hard to graph. So, but it is useful. It is a real number, so it can be used. So we try to stick with numbers that are perfect squares when we're dealing with our chart because they give us easier numbers to graph. So we pick 4, the square root of 4 is 2. And we pick 9, the square root of 9 is 3. So my chart doesn't go up to 9, but I go up to 6. So 4, x is 4, and there is the f of x is 2. So there's the graph, and this is how it looks. Notice it's a curve, and it is the square root. It's also, if you talked about what it really was when I mentioned the quadratic, it's inverse of the quadratic, whereas you have a sideways u here, so u would be down here, and a parabola, in other words. So we're just dealing with the top part, the positive values, because down here we'd have negative numbers and we'd be in the imaginary zone. So let's see what those letters have effect on our graph. So here we have f of x equals c times f of x. Notice c is going to be greater than 1, so we're talking about numbers greater than 1, positive numbers, which causes the graph to stretch. And let's see what that means. So f of x, if we use c equals 2, it's going to be multiplied by square root of x. So as we said, we take x as our 0. I left the first function there so you can see it. So f of 2 times x, so f of x is going to be taking 0 for x, and square root of 0 gives you 0 times 2 gives you 0, so we're still at the origin. So we'll pick 1. Square root of 1 is 1 times 2. Notice the value is doubled. It gets times 2. We pick 4. Square root of 4 is 2. 2 times 2 now gives you 4. So when we graph 2, well, 1, 1, I'm sorry, 1, 2, 1, 2, there's the new graph. And now 4, when we graph 4, and it comes out to be, I'm sorry, I skipped 1, 1, 2. So 1, 2 goes up to here. Notice the value doubled. when we go to 4 on the f of x graph, it's 2, but when we go to the f of 2 times that amount, the square root of 4 is 2. 2 times 2 is 4. So when we go to 4, notice the value doubled. It was on the f of x equal the square root of x is 2, but on the new graph, it's 2 times that amount, so it doubled. Now it's 4. So notice how much higher the red graph is stretched. So just because of the 2. So the c, when it's greater than 1, it will cause the graph to stretch. So that's something you should know. It's in front of the radical sign, so that it means it's a multiplier. The opposite happens when we have c is between 0 and 1. We're talking fractions, so it's going to be taking a portion of the size or shrinking our graph. So if we take half of the square root of x, and notice what happens when we again use our numbers. I did leave the f of x values there. So 0, square root of 0 is 0, half of 0 is nothing, so we're at the origin. 1, square root of 1 is 1, half of 1 is 0.5. So now when we go to 1, x was 1, 0.5 is right here. It's halfway between 1 and where we are on this graph. So it's the halfway point, 0.5. So notice it went down or shrunk by half. Well, let's look at 4. When we pick 4, square root of 4 is 2, half of 2 is 1. So we pick 4. Notice it's the halfway point, whereas in the f of the x value, 2 was way up here in the f of x value, in the x of f for square root of x. That was 2, but now in the half of that value, we take a look at it. Now notice it's half the size. So it's causing this to shrinkage. And I now have 9, square root of 9 is 3, half of 3 is 1.5, and 9 is down here, and 1.5 would be about halfway up here. So it'd be like there. And again, notice it's still underneath the blue graph, so it's shrinking. So you should know when you have fractions or decimals that are between 0 and 1, it's going to cause multiplied by your radical, it's going to be a shrinkage. So there's some other things that happens. Here we have f of x equals x plus or minus a, so there's now a underneath the radical sign. And a, if it's less than 0, so we're talking negative numbers, it's going to shift the graph. So it's going to cause it to shift to the right. If a is greater than 0, it's going to shift the graph to the left. So let's take a look at this question. F of x plus 5 is f of x equals x plus the square root of x plus 5. So let's see. Now we were supposed to pick numbers. So let's be careful. Again, we're trying to pick all real numbers and stay out of the imaginary zone. So if I pick 1 or 0, usually we would start with 0. 0 plus 5 would give us the square root of 5. And the square root of 5, that looks like 2 point something. So I'm not going to pick that. I want to pick numbers that give us good square root values. And if you remember in my other video, how do we solve square roots? I would recommend you watch it. I'll go over just a couple of them real quick. X plus 5 is our function and equal to 0. So I want to set it equal to 0 so I can solve it. If you remember how we did it, we square both sides. That way we can get rid of the radical sign, and the square root and the 2 cancel out, giving us x plus 5 equals 0. Now all I got to do is solve for x. Minus 5, minus 5. 5's cancel out. X is equal to negative 5. That'll give me the number that I need to give me a 0. So if I use x equal negative 5, underneath that, that'll give me negative 5 plus 5 gives me 0. Let's try one more, see if we can make sure we understand what we're talking about. I notice we got, say, 3 down here. So let's try it with 3. We are set our function, x plus square root of x plus 5. We want to make that f of x 3. So again, let's take this function and square both sides. what that causes the radical sign to disappear and the exponent to disappear, bringing out the x plus 5, and now we have 3 to the second power, which is 9. And if we minus 5 from both sides, minus 5, we'll get the value of x. X is equal to 4. And that's going to be our point. So x will equal to 4. So when we go over here, we use 4, and the f of x will come out to 3. Well, let's make sure. 4 plus 5 is 9, and 9, the square root of 9 is a perfect square, is 3. So we got our points. So you should be able to fill in the rest. I just want to go straight to the graph because we're going to graph our points. So if I can get this out of the way here. Notice, and let's go full screen. So notice what happens with that, with this one when we graph it. -5, 0 is there, and hopefully you can figure out what this one is, this point, and solve it. Hopefully you'll solve it and see that x is -4, 1, and hopefully you solve this point for 2, and what do we got? -1, 2 up here, and we already solved 4, 3, and hopefully you solve this point, 11, because 11 plus 5 is 16, and the square root of 16 is 4. So we got 11, it's halfway between there, and it's 4. So notice how this is going up, but notice where it started from. We at our other function, f of x equals 0, f of x equals the square root of x. Notice it started at the origin, but now it's shifted over to the left. 5 spaces is between the -4 and -5. So a positive or number has a shift to the left. So when you add a to the square root value, it shifts it over to the left. And the opposite is true when you subtract. So if you subtract, it's going to shift it to the right. So any number less than 0 is going to shift it to the right. So I left this chart for you to try, so you to fill out and see if that's true. Okay, we have now f of x equals the square root of x plus or minus b. So b also has an effect on our graph, where b less than 0, so we're talking numbers that are negative, has a downward momentum and it shifts it down on our graph. So here we also have a plus 3 in our function, so we're adding 3 to that, and what happens when you add, it has an upward shift, so it'll take your graph and shift it upwards. So here we got square root of x plus 3, so if we use 0 for x, square root of 0 is 0, so we can use 0, and 0 plus 3 is 3, so we would graph the point 0, 3. Let's try x equal 1, square root of 1 is 1, and 1 plus 3 is equal to 4, so we can graph those points. Here are some other points I hope you'll find. If we take 9, what's the square root of 9? If you said 3, that's correct, and 3 plus 3 equals 6. So let's graph those points, and notice what's going to happen to this. It will cause a shift upwards. So I graph those points. 0, 3 is up here now. Notice f of x, where the square root of x was at 0, 0. Well, when you have a plus 3 to that value, it causes the curve to shift upwards. So it added 3 to it. So here's the other points that I hope you found, and notice the curve. So it's now upwards shift by 3 because of the addition. And here's another one. The opposite is true when you take away b, where b is less than 0. So when you're dealing with numbers that take away or negative numbers that are added on to our square root value, it takes it and brings it downward. So you take a look at these charts and graph it and see what you get. So it's like a y-intercept. So hopefully you remember that plus y equal mx plus or minus b. It's like a y-intercept. All right, here's some questions. Let's see if we can get them. So hopefully you remember. The graph of the function below will shift the graph left or right. True or false? Well, I have square root. So if it's going to shift it left, it's got to be on the inside of the graph. This is on the outside. We just saw that a second ago. If it goes down, if it's outside of the square root sign, it's going to cause it to go down. So this is false. And let's put a stop to that. This is false. But I don't know why it's not working, so give me a second and let me get it. Okay, let's see. So I said false, and there it is. It is false. So here's another one for you. So here's another function. Will the graph shift up? True or false? Check your understanding. We watch the tape because there are a lot of definitions that you need to know. So check your understanding. Hopefully you understand it. Here's some more questions. Will the graph shift right? So we'll talk about it in class. Here's another one. Will the graph shrink the curve? So will the function shrink the curve? Good question. I want to go into sketching. When we sketch our graph, they're going to ask us to make a little drawing of it. So here's our function, and here's our table, and we have a graph hiding. So see if you can sketch it based on what you learn. But I want to teach you something that'll help you out with the graphing calculator. So I have my graphing calculator here, and here are our steps. So let's get it up. Press y equal. So there's your y equal. And then type in your function. So let's get a function. So let's get a function. Okay, got my function. Let me get my calculator back. Type in a function. Now you can use the square root button, or you can use the exponent button for which is the caret with 0.5. Why 0.5 is because the exponent of 1/2 is the square root. So we can change 1/2 to 0.5, and I find that a lot nicer than trying to type in fractions on the calculator, but you should know that anyway, just in case. But that's a nice shortcut. So let's try first typing in the square root button. So we got y equals, second square root button is over there by the x. And now type in our function. So x plus 6. Notice it's under the square root sign. Now we got to come over once a little bit out of that square root sign to add 3. And then press enter. There is our function. It's typed in. Let's type it in our second y2 so we can see what it looks like if we use the exponent button. So you got to put parenthesis around your function. There's the x plus 6 plus, I'm sorry, not plus, we got to close the parenthesis because that's we want underneath the square root sign. So we're going to take that up by using our exponent button to the 0.5. So that radical is going in parenthesis, and that part is taken up to the 0.5. I'm using a TI-84 plus in color, and it does a nice job, by the way. Inspire is a good calculator too. TI Inspire. So I got to add 3. So add 3 to it and enter. Okay, so notice how these look different, and if it's correct, if we graphed it correct, it should come over, it should graph over each other. So one will be in blue, one will be in red. So Now select Zoom 6. So now we got to go to Zoom 6. That's our standard window. And watch the graph. Here's the magic. Notice it's starting over there, and it's continuous and going that way. Notice the red line is going right over it. And it's colored over it, so we know that our graph is correct whether we typed it in square root or exponent. So I hope you enjoyed this lesson. So now you have a lot to learn and go on, so please let me know how we're doing. And if you have questions, write them down, bring them in the classroom, watch the video again if you need to. It was a good lesson, a lot of stuff we got. So bring in your questions, and Dr. Rob is signing off. I will see you tomorrow. Bye-bye.